All right, so for those who didn't join us yesterday, so I'll be teaching you discrete mathematics and graph theory. Okay, and yesterday was just about introductions, like we introduced ourselves. So the today's lecture will be all about, as I had mentioned yesterday, what is this course all about, and most important question, that why are we studying this, right? Why you as information technology engineers or computer science students do require this course at all, right? Why is this relevant to you, right? So before I go into those details, let's first have a look at our course structure, course setup, course policies. So this is going to be our learning environment. Since we know because of pandemic we are in this online setup, so these are basic tools that we are going to use for our learning environment. So primarily we are going to have our classes via Google Meet, and for recording I'm using Zoom. Regarding evaluations, we will be using Gradescope, which I know you have used in your earlier semesters as well. And the new thing which we are going to use in this course is Piazza. Okay, so Piazza is like you have your social networking sites, Facebook, Twitter, Instagram, and all. Piazza is an academic interaction site. Okay, so all of you are now registered on it, so please make use of this. Okay, please make use of this tool. So I prefer the classes to be interactive. I'll take live lectures, and I'll also be recording them, in case someone by chance misses it or you require it for revision. So it will be there, recorded lectures on YouTube, but main will be live lectures. Okay, and the prime purpose of having live lectures is so that, whenever you have even a small doubt, you should raise it up, right? But what about doubts after class timings? Okay, for that is your Piazza. Anytime you have any doubts, please post a question on Piazza. You can also do it anonymously if you think you don't want to give your name. And it's not just instructor will answer. If someone has posted a question and you know that, like we do in offline classes, you can answer it. Okay, so Piazza is all about creating a class environment in this online setup. Okay, so I hope all of you will use it readily. Okay, these are some important links which I've already shared with you. The course web page. Main use of course web page is that if by chance sometime you miss a class, you'll get to know what all topics we have studied and what are the references from where you can refer to them. Okay, and class link which we already know. So coming to course policy, I think by now you already know what is the course policy. In general, it is 30% midterm, 60% major, and 10% is internal assessment. Okay, I don't give marks for attendance. I think there's no need to give marks for attendance. As long as your concepts are clear, you're following up course, it's sufficient. So my assessment marks are normally either based on quiz. So if I give you something to read, I'll take a quiz, or it will be some assignments. Okay, so I'm not yet thought about it. If I get some good programming assignments, which you can also add on CV, which are related to this course, we can connect them. I would prefer to have a good assignment which you could add on to your CV as well, right? So although I said I am not very fan of attendance even in offline setups, but I appreciate people to join class regularly. Okay, because normally what I teach in class, the logical questions I ask in class, the same questions I prefer to ask in evaluation also. Like if you follow up class, I'm sure you won't require any practice at the exam end. Okay, so in that case there's a flexibility, but as long as you're corporate, I'll not have any issues in that. So major, because of this online setup, as you already know, has been split up again. You have 30% written, 20% Viva, and again 10% assignment, which makes it 20% assignments. So that means I can give a good programming assignment to implement something of discrete maths, right? So that's something you should be prepared about. We'll have some interesting programming assignments or quiz at regular intervals. Okay, so this is going to be your course policy. Of course, it is subject to changes as and when if there is some change by dean academics. Okay, any questions about course policy, anything, any issues that you have or any clarifications? I would prefer people you type on chat, because if you unmute, there's a lot of noise and echo. Okay, you can type in on chat box. I have a separate device by which I'm having a look at all your chats, so you can, any questions, any clarifications on course policy? Okay, great. Okay, now coming to most important thing, something which I will never tolerate. Okay, I will tolerate if you are late. I'll tolerate if you don't submit things. But this is the thing I'll not tolerate. That is plagiarism. Anyone knows what is plagiarism, by the way?
Copying others.
Exactly. Copying other stuff, right? Like in simple words, it's copying. Okay, but like if you go by technical definition, what plagiarism means, it's actually presenting anyone's ideas as your own. As you can see from the picture, someone has an idea and it's just taking it. Okay, so plagiarism is the most vulnerable enemy of academic honesty. Okay, this is the only thing I'll not tolerate. Okay, and uh, okay, so don't be a copycat. Think for yourself. Okay, and defaulters will be penalized. I am very much against plagiarism. Okay, I'm okay if you're able to do 10% assignment, 20%, even 5% assignment, but don't copy from others. Okay, just think for yourself. Jitna aapse ho pata, that's okay with your efforts. Okay, don't copy paste. And I'm very strict about that. I have given zero to people in exams about it. Okay, this is the only thing I'll not tolerate. And why I am having a specific slides here is because since I'm teaching you for the first time, please understand that this is the only thing I'll not tolerate. Okay, so I hope I don't see any such cases. Okay, and it's not just about copying, it's also about, like, if you have some assignments, suppose I give you a programming assignment and you don't 100% copy, but you discuss your ideas, like you have to code up something, so you brainstorm on some ideas and you have discussed it with some friend. So what the best way of being a professional is, you in the references you cite that I have discussed this with you, so that whoever has given you some idea, they get the due credit. Okay, and this is a very important quality to develop as a professional, to give due respect or due credit to where you have referred to. Okay, so I hope on that end everyone will remain safe. Okay, now let's come to our course itself. Okay, which is discrete mathematics and graph theory. So let us first do a kind of lexical analysis. Okay, so if you look at this course name itself, there are two key phrases that you can see here, right? One we have is discrete mathematics, right? And other is graph theory, right? So let's see lexically what do they mean, so that in case we get some idea into what this course will be all about. So let's first focus on discrete mathematics. Okay, so let's keep it interactive. So before we come to what is discrete mathematics, what is mathematics class? Okay, you can type in the chat box. Okay, no need to unmute. Any rough idea? I don't need exact answers. Anything that you can think of. What is mathematics? What comes to your mind when you hear the word mathematics?
Numbers.
Okay, numbers, art, calculations. Very good. Language of science, calculations. Very nice. Excellent. As you can see, there's no such, calculative stuff, discovering pure logic, reason. As you can see, there's no coherence in the answers, although none of them are wrong, all of them are correct, right? And that's what mathematics is all about. You study topics like which help you to define quantity, like you have number theory, or as some of you have mentioned, some numbers, analysis of data, or you can study some structure, right? You have an algebra, what kind of structure is made from numbers. Or you can study something about space, like we have done in our high school and higher secondary classes, geometry, right? Or in mathematics you can study about change. How do things change from one state to another? So all these ideas which you have written, or some of which I have written on screen, all these are part of mathematics. Okay, now why there is no one definition that everyone is coming up to, as Wikipedia also very cleanly accepts that there's no general accepted definition of it. Okay, that's why you can see there's no coherence. If I ask you something else, you will quickly see that all answers will resemble on same definition. But this is what mathematics is all about. It's about study of different concepts which may relate to numbers, which may relate to space, which may relate to geometry, which may relate to analysis. But definitely there's no one accepted definition, right? And that is how it is, because it's a science is somebody in the beginning had it in a very nice concept. It's an art, right? Art is indescriptive. You cannot define it using some boundaries, right? So that is mathematics. So we all have fair enough idea what is mathematics. Now, what is discrete? Any idea what could be discrete? Exactly, which is not continuous. Anything else? Anything you can correlate with discrete? So discrete, as Ashish, Irtika have correctly written, something which is not continuous but is distinct. Distinct means you can easily make it out, right? Like if I see there are 69 students, I can clearly say there are 69 individuals there. Something which is unconnected, there is no connection between different components. That is what you call discrete, right? So something which is unique, distinct, unconnected, all these are the names what we say for discrete, right? Now if you combine the two, so what is discrete mathematics? It is the study of those mathematical structures which are discrete and not continuous. Okay, so study of those kind of structures. So we saw there are different kinds of structures in mathematics. There can be numbers, there can be geometry, there can be analysis. So all those mathematical structures, but those of which are discrete and not continuous, is what is the study of discrete mathematics all about. Okay, so if I try to kind of categorize, okay, so suppose I talk about real numbers, okay, and I write here two real numbers, say 2.5 and 2.6. Is there any real number in between them? Just a curious question.
Yes, ma'am.
Very good. There is, and there are infinite, right? As you correctly pointed. How? I can keep on writing like 2.5111 till infinite precision, and I'll find infinite number of numbers between the two. So is it discrete or is it continuous? Excellent. It is continuous. Okay, why is it continuous? Because if I just look between 2.51 and 2.52, I can start adding numbers behind it to increase its precision, and they can be infinite. And that makes it continuous. There's no break. There's no specific break between two values. Okay, and that's why real numbers form in continuous domain. So can they be an object of discrete mathematics? Okay, so I gave you the definition that discrete mathematics is study of those structures which are discrete. So they cannot be. Can you tell me any numbers which can be discrete? Any number system that you have studied which is discrete?
Prime number.
So prime number is a subset, you can say, of natural numbers. Very good. So natural numbers, integers, whole numbers, all of them kind of are subsets. So all of them are discrete. Why? Because if I suppose say I'm talking about integers and I'm writing 3 and 4, is there an integer between them? I'm not talking about real number, I'm saying integer. Is there an integer between 3 and 4?
No, ma'am.
Exactly, right? So that means 3 and 4 are individuals and there's nothing between them. Whereas if you just look at 2.5 and 2.6, as you agreed, there are infinite points between them, right? So that means if I have to study discrete mathematics, the number system which I am dealing with is things like integers, natural numbers, right? The operations I'm studying are on them, right? Now, if you take the analogy, right? The analogy is, suppose I have a digital clock and an analog clock. Okay, so one is my digital clock and another is my analog, the simple wall clock that we have. So again, can you tell me which is discrete, which is continuous? Excellent. Digital is discrete. Why? Because you will see specific digits coming on your digital clock, right? And analog is continuous. Excellent, right? So anything, any mathematical structure which is discrete rather than continuous is falls under the category of discrete mathematics. Okay, and we already saw one example, like real numbers which are continuous will never be part of discrete mathematics. Okay, but rather what we have objects like integers. Okay, and there are some more objects like graphs, like statements in logic. All of them are distinct, they're not continuous. Okay, we'll see them in detail. But anything which is distinct, anything which is unconnected, wherein there is no continuity, all such mathematical structures are under discrete mathematics. Okay, so if I just kind of summarize using this diagram, so you can see there, eventually mathematics on this basis can be divided into two classes: discrete mathematics, which deals with discrete objects, and continuous mathematics, which deals with continuous objects. Okay, and you can see what all is under continuous: calculus, geometric spaces, real numbers, all of them are under continuous mathematics, because they are something which is continuous, there's continuity. Whereas things like integers, okay, graphs, like you can see this is a graph, so it does not have infinite number of nodes, there's a finite number of objects there, so it also comes under discrete mathematics. Okay, so anything which gives you a concept of being unique, disconnected, or distinct, all those structures come under the category of discrete mathematics. Okay, and as mentioned in the comment below, this may not be disjoint. A lot of times you use techniques in continuous mathematics to solve problems here, right? But the way we classify them into two categories is on the basis of what objects on which they work. If you work on discrete objects, it's a branch of discrete mathematics. If you work on continuous objects, it's continuous mathematics. Okay, but there's no disjoint line that you cannot use continuous mathematics to solve problems in discrete mathematics, or vice versa. Okay, so this is all about it, like a very overview idea of, based on the words of this subject, discrete mathematics. Mathematics which deals with discrete structures. Okay, now just to wind up this concept of discrete mathematics, let me draw two plots, plot 1 and plot 2. Okay, just to have a complete picture of discrete mathematics. Okay, and I am plotting some x, y axes, some values here. Okay, and some values here. Just to give you an idea in terms of plot, how does discrete objects and continuous objects look like? So what is plot 1? A discrete plot or a continuous plot? Okay, does everyone agree 1 is discrete? How do you conclude that this is discrete? Because all the objects, all the values that you had on this plot, they were distinct, they are not connected, right? But if you move to plot 2, this is clearly continuous, right? Because if you find any 2 points on this, same concept applies. There are infinite number of points between them, and all of them are continuous, right? So this is how objects, even if you plot them, how would discrete and continuous look like? Discrete will be disconnected, distinct, whereas continuous will, kind of vary smoothly, and they'll all be kind of connected with each other. Okay, is that clear, more or less, the basic idea of discrete mathematics, pictorially as well as theoretically? Is this clear, class? Any questions? Okay,
No, ma'am.
excellent. So that was our first phase of our course, which was discrete mathematics, right? Now coming to the second part, which is graph theory. Okay, so before we come to graph theory, obviously the first question is, what are graphs? Any idea what are graphs? So I don't need any formal definition, anything that buzzes your mind when you hear graphs, whatever you have heard so far.
Geometrical way of representing data.
Excellent. Visual representation of data. Okay, so you can see there are some similar ideas coming in. Excellent. Graphs, whatever we have studied till this level, you would have studied it. They're always used to kind of represent your data, right? Most of the time, what we have seen till this level, you would have seen is mostly in statistics. You would have used graphs, right? Or maybe in science to show some plot, you have used graphs, right? But graphs are one of the most powerful tools for us as engineers, and specifically as computer science engineers. Okay, and I'll give you multiple examples where these graphs are relevant. Okay, so overall idea is correct, as most of you pointed out. This is a representation of data, right? But now, today, what I'm going to introduce you is slightly more elaborate version of what you mean by representing data. Okay, so let us try to see that. What do I mean when I say I'm going to represent data? Okay, so first thing that I can see on the screen is graphs are mathematical structures. Okay, so this is first thing that you need to digest. Okay, so graphs are not some alien objects, they are also a mathematical structure. Okay, and from previous slides we already know it is going to be a discrete structure. There's not going to be any continuity. Okay, so first thing you need to understand is it is also a mathematical structure. So that's first thing. Now, what is this mathematical structure used for? Okay, let's come to that next. This mathematical structure, as you already mentioned, is used to represent data. Okay, now what kind of data? These graphs or mathematical structures are used to represent pairwise relation between objects. Okay, so let me give you an example. Let's suppose I have this class of 2020 batch. Okay, and suppose there are five students. I'll just consider five for now. Okay, so these five students is what here in this definition, I'm going to relate to this definition, are known as objects. Okay, now graphs are mathematical structures which are going to tell the pairwise relation between objects. Okay, so these objects here are students. Now, what are graphs going to do? They are going to tell us pairwise relations. Pairwise relation means, like, if I give number to all the students, it's going to tell me what is the relation between 1, 2, 1, 3, 1, 4, 1, 5. Pairwise, what is the relation of all the uh, objects or students, right? So suppose we have this class of students. So suppose the relation we are trying to see is friends. Who are friends with whom? Okay, so suppose I say 1 and 4 is a friend. So whoever is a friend, I'll make a line or edge, as we say in technical definition, between them. Okay, so 1 and 4 is a friend, so I'll draw a line between them. 1 and 2 is not a friend, so there's no line. 1 and 3 is not a friend, so no line. 1 and 5 is also a friend. Okay, so now suppose I get this kind of structure at the end. Okay, so this structure that you came up by defining the relation, pairwise relation between objects, this is known as a graph. Okay, so you can see it's not just about any general data. Any data that can be represented in form of pairwise relation between the different objects can be formed as a graph. Okay, so it's much beyond the graphs you have seen in your statistics course, or your simple plots in your science course. So any problem which can be structured in this form, wherein you have different objects and you need to define some relation between the objects, that can be represented by this powerful mathematical structure which is known as graphs. Okay, and if I go by the technical definition of a graph, so graph will necessarily have two things. Okay, so the two things that will be there in the graph will be, one is the set of vertices. Okay, and other is the set of edges. So vertices means what? Vertices means these nodes, the objects between which you want to develop some relation. Okay, and what is edges? Edges are the connections between those objects. Okay, so let me just repeat and then I'll recap it again for you. So what are graphs? Graphs are a mathematical structure, okay, which are used to represent data that we know, right? But how do we actually represent that data? So all the objects that are there in our data, we develop pairwise relations between them. If there is a relation between the two objects, we make a line or an edge between them. If there's no relation, we don't make a line. And the overall structure which comes out after defining these relations is what is we call as the graph. Is that clear? The overall idea? We are going to study this in detail, but you should know the technical definition now, like how we are going to model things in graphs. Is this more or less clear? The class analogy?
Yes, 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 ma'am.
Okay, excellent. So, so what do we have? Graph are mathematical structures, and how do we define them? To define any graph, you need to define two things. One is the vertices, and other is the edges. Like you can see in this diagram, how many vertices are there based on what you have understood? Anyone? How many vertices are there in this source diagram? There are 6, right? Because vertices means the nodes. And how many edges are there? There are 7 edges. So you have 1, 2, 3, 4, 5, 6. Where is the 7th edge? So you have 1, you have 2, you have 3, you have 4, you have 5, you have 6, and you have 7. Right? So there are 7 edges. Great. So this is what is your graph. What is it? It's a mathematical structure defining pairwise relation between different objects. Right? Now, before I move to then what is graph theory, let me again give another example so that the concept of graph is clear. Okay, so suppose what I need to do, I have an office where there are 5 PCs, okay, and 5 PCs are connected to each other in some fashion. Can you tell me how can I model that as a graph? What should be the vertices? What should be the edges? Okay, I'm again repeating, we have an office which has 5 PCs arranged in some order. Okay, if I need to model this computer network in an office in form of a graph, how can I do that? What should be my vertices in this case? Excellent. Vertices should be the PCs, right? And what should be the edges then? Very good. Excellent. Edges should be the connections. Okay, so like if suppose I have 5 PCs, okay, so fifth one is suppose the PC of a boss, okay, and they are connected via wires in this setup. Everyone is connected to the boss and they are connected in form of a square. Okay, so you can see PCs are your vertices and edges are your connections, the wired connections that you have. Okay, so this is how you represent the data. Okay, we'll see some more interesting examples in the coming slides, but I hope the idea of modeling real world problems as graphs is clear. Is that clear to everyone using this computer network and class analogy? Okay, excellent.
Yes.
So now we know what is graphs. So what is graph theory? Graph theory is nothing but study of these graphs. Study of graphs means you study different properties of graphs. Like What is the maximum number of nodes a graph can have? What is the maximum number of edges a graph can have? Okay, how many edges does a node have? So all the properties of graphs, where do you study that? All the study of such properties is known as graph theory. Okay, and this is not irrelevant. We'll see how all those properties are relevant in practical examples. Okay, and this graph theory is nothing new, but it's also a branch of discrete mathematics. Okay, so if you consider discrete mathematics as a bigger set, so graph theory falls into it, because as we know, graphs are discrete objects. Okay, and if you recall, what is discrete mathematics? Discrete mathematics is the study of discrete objects. So graph theory is in itself inside discrete mathematics. Okay, now any one of you might ask question, then why the name of course is not just discrete mathematics? Why is it discrete mathematics and graph theory? Okay, and there's a very solid reason behind that, and the reason is, no doubt that graph theory is a branch of discrete mathematics, but as you will see in your coming courses as well as this course, graph theory has a very important relevance in computer science. Okay, and to highlight that special status of graph theory, it has been given a special status in this course, as well as there will be special focus on this component. Okay, otherwise, to have a full picture, the graph theory is nothing different subject. Okay, it is a subset, or it is a branch of discrete mathematics only. Okay, is that clear to everyone? The both parts of the course. See, this is very important. These are just overall picture, bird's eye view of the course. What is discrete mathematics and what is graph theory? This is clear to everyone.
Yes, sir.
Okay, so
Yes.
just to recap, discrete mathematics was the study of mathematical structures which are discrete. Discrete means they are distinct, they are unique, they are unconnected. Okay, and then we move to a special status or special branch of discrete mathematics called graph theory, which is study of graphs. Okay, and what was graphs? Graphs were again discrete mathematical structures, but what are they used for? They are used for modeling the pairwise relation between different objects. Okay, so that was the lexical analysis of our course. Okay, any questions till this point? Okay, so I assume no. Now coming to a very important question, how is discrete mathematics relevant to us? Okay, and by us, I don't mean computer science students or IT engineers. I mean ordinary people. I'll come to computer science also in a while. But firstly, how is discrete mathematics related to us as ordinary people? Ordinary people means like in our daily lives, can we find any practical use of discrete math? Okay, so let us answer some this question first. Okay, so let me just. Okay, let me just bring the annotations back. Okay, so now if you want to answer this question, that is discrete mathematics relevant to us as ordinary people, so so answer to this question is yes. Okay, and I have shown a couple of examples where different topics in discrete mathematics get connected to our life. Yes, excellent, Ash. So I'll come to that as well. So let's start. Okay, these what you can see in the highlighted colors are the various topics in discrete maths. Okay, and I have given some questions which are related to these topics. Okay, so let's start with logic. So if I give you some argument, okay, and you have to check whether that argument is logically sound or it is a false statement. Okay, how do you do that? Okay, so suppose I say that all Indians hate cricket. Okay, so is this a universally true statement? Can I generalize it? No, it is not. Okay, certainly I cannot say that even in US, although in US the culture of cricket is less, right? So how do I check all the cases and get to know that this statement is correct or it's wrong. Okay, all that can actually be modeled using a concept in discrete mathematics called logic, okay, which we'll study in this course, of course. So that was logic. Okay, now let me ask another question. So if a leap year, as we all know, happens after every 4 years, based on how leap years are defined, okay, and if we consider general elections in India, they are held after every 5 years. So now, if I ask you a question, how frequently will election be held in a leap year? Can anyone attempt this question? So the question is, leap year happens after every 4 years, and general elections are held every 5 years. Okay, how frequently will election occur in a leap year? Okay, so somehow some people are attempting the question. The answer is, how do you answer this question? Don't give me the answers. What are the techniques you use to find the answer? I don't want the answers now, right now. What are the techniques you are going to find? Right, you are writing LCM. Like, what is this LCM and all this all about? All this belongs to number theory, right? You are dealing with numbers and there's some properties. So definitely it's not something disconnected, right? So that covers the two main topics. Now let's come to the other question. Okay, suppose you are a fashion geek. You prefer to wear different clothes every day, and you have you have a couple of jeans and couple of t-shirts, right? Now you want to find out how many different outfits, different combinations you can make from your clothes in your closet. Okay, so what technique comes to your mind? How can you make do those calculations? Different combinations of t-shirt and jeans that you want to mix and match, or dupattas and shirts and whatever combinations you want to match. What idea can you use? Excellent, Japsimar. Combinations, permutations and combinations, right? Again, that is also a discrete mathematical topic which falls under counting. Okay, then coming to the topic which I think Arsh had pointed out in the beginning, right? That suppose you have your home is located at a very good location, which has multiple routes to reach to your college, right? And your class starts at 10, and you just woke up 15 minutes early. So how do you drive fastest to your college? Okay, how do you get to know how do I reach to my college fastest? Anything, any modeling that we have studied? Yes, displacement is right, but anything that you have just studied, can you model this as graph? Can you model a road network as a graph? Any idea? Just let us give a picture. How can I model a road network as a graph? What should be very excellent? Ketan gave a very nice, very appropriate weighted graphs, but we'll come to that later. So what should be the nodes? So far in the class, I have not talked about weighted graphs, Dijkstra algorithm, all these technical things. Let's keep it uniform. सब बच्चों के लिए uniform. अभी तक हमने सिर्फ nodes और edges पढ़े हैं. So tell me in this context, if I want to map a road network in form of a graph, what should be the nodes, what should be the edges? Exactly. So Zishan says in terms of two nodes, but in general, if I want to make a road network of entire city, nodes should represent the place, right? Like home and college. And what should be the edges? Excellent. Right? Now, if I have modeled my entire city in form of roads, okay, sorry, in form of a graph, okay, and now this is my school and this is my college. Okay, now if I have to find how fast I can reach to my college, how do I do that? Right, I'll simply find the shortest part on this graph and I'll be done. Right, so you can see how relevant is this to practical problems. Okay, and actually, like I can give you a context that recently there was a project at IIT Delhi wherein Swiggy, which is a food delivery a company, collaborated with IIT Delhi so that they can find an optimum path by which food could be delivered to all. So you can see the basic idea that they used in project was just modeling graph. So you can see how very heavy deemed projects are ultimately rely on such simple concepts. Of course, they will require some learning and all, but underlying concepts are still same. That is how well you can, in your mind, visualize a practical problem and model it in the concept. And this is very important part of this course, which most people skip. See, I'm going to teach you sets, functions, relations, which you have already studied in higher secondary school. But why we are repeating it here is so that you can connect it to computer science and relevant problems. You develop your engineering mind. Okay, so this is what I expect from you. Given a problem, you should be quickly able to connect it to these problems. Okay, so that was all about graph theory. So coming to other examples. So suppose you take a debt from your friend and you mortgage, suppose your very costly watch, okay, and your friend is not very good friend and he or she has asked you to pay a compounded interest annually for this, okay. So you need to calculate, say, over your lifetime, say 40, 50 years, how much you're going to pay, right? What concepts do we use here? The concepts that are used in such a case of problem, when you want to repeat a particular formula over a repeated number of iteration, there's a concept of recurrence, okay, which we'll also study in this course. And the last thing, that suppose you apply for a lottery, what are the chances of your lottery, right? We have seen all this. If you play a die game, right, what are the chances of you winning? How do you determine all that? All that is determined by using concepts of probability. Okay, although probability is not to be covered in this course, there's a separate course for this taken by maths department, but probability is also a discrete mathematics branch. Okay, so is this clear? Like these very simple questions, how they are relevant to us, like as ordinary people, all of us, not just engineers. Anyone can face these questions, right? So is it clear how discrete mathematics is important to us as ordinary people, to everyone?
Yes.
Okay, excellent. So this was a very general concept, right, to us as ordinary people, right? But the next question you should ask me is, we have still not answered this question, that why is it important to us as IT engineers, or why is it important to us as computer science students? Okay, and that is what we are going to answer next. Why or how is discrete mathematics related to now computer science? Ordinary people is fine, but why and how is it related to computer science? As IT engineers, why do we require to study this course? Okay, so before we answer that question, a quick question to you. So, what is computer science? Not computer science and engineering. What is computer science in general? Yes, class? Nobody knows what is computer science? What comes to your mind when you hear word computer science? The binary science? Okay, excellent. Science regarding computers. See, please try to write on chat because sound is sometimes blurred. Science that deal with computers. Okay. Study of programming languages, study of languages, deep study about computer. Okay, interesting. Study of algorithmic processes, observation of computers. Excellent. But in general, like all of you have been writing so many things, study of programming languages or how do computers work, but what are you ultimately using computer for? What do you use it for? Exactly. You are trying to solve some problems using computer knowledge, right? And that is actually what is computer science. Using computer technology, okay, and all your answers of programming languages and functions and whatnot, whatever you have written in the answers, all of that is correct. all that comes under the domain of computer technology. So using computer technology to solve problems, that is actually computer science, right? To ease out your problems, you use the technology. Now, that is what we say is also machine, right? But here we are not talking about any machine, we are talking about specifically computers. Using computer technologies to solve our problems, that is what we say is computer science, right? Now, the question is, in this curriculum, your IT course, BTech course, you will study a lot of subjects which will talk about these computer technologies. You will study compilers, you will study database management system, you will study AI and whatnot. So all these subjects will be about computer technologies, right? But this course, discrete mathematics, it is about mathematical foundation of how to solve problems. Okay, so if AI is solving some real world problem, so we cannot say AI is the solution. AI is also at the back end supported by some foundational techniques. Okay, and those foundational techniques is what we study in discrete maths. Similarly, database management system helps you to handle all your databases. But database management system also has some foundations which lie in discrete maths. So discrete maths is like the foundation of how do you solve those problems actually. Okay, so let me pose some questions to you and let us see how do you respond. So how did Google manage to find or build a fast search engine? Today in this world, I don't think there's any person who has ever used internet and not used Google. Google has kind of become synchronous with using internet, and it has such a fast and efficient search engine. Any ideas you have heard about how Google is able to develop such a fast search engine? Okay, a number of keywords are being used. So somebody is saying cloud, wireless network, anything else? Quantum computing. Google didn't start with quantum computing, they are leaping into it. But in the beginning, they didn't use quantum computing. But still, I'll note that fast, efficient algorithm. Does anyone know what is the name of their algorithm on which this is based? Jameel? Jameel, Irtika, you mentioned algorithm. Do you have? No? There's something called page rank algorithm. Yeah. There's a very famous algorithm by Google called page rank. PageRank is the PageRank is the backbone of Google. Okay, it's a super optimized algorithm, and we'll talk about it when we come to graph theory. But PageRank is what is the core of Google. Google developed itself on PageRank. Okay, and then eventually there were different versions of PageRank, but yeah, that is where Google developed. Okay, so let me keep these words here. Okay, so algorithms. Now, what about foundations of internet security? What do you think? What are the key concepts which lie at the back end of internet security? Excellent. Cryptography. Encryption. Very nice. You know all the technical terms. Okay, so if I look at your answers, most of the answers that you gave, the key terms you gave, uh, for answering these questions were algorithms, data structures, parallel, quantum computing, cryptography, networks, right? Firewalls also comes under networks. But if you look at the foundation of all these subjects, the foundations lie on logic, on number theory, on graph theory. Okay, so computer networks at the back end uses graph theory. Algorithms at the back end use counting, number theory. Okay, so all these heavily relying concepts at the foundation have those concepts which lie in discrete mathematics, and that is what makes this subject special. Okay, now I would like to wind up, although I'm not still done with the motivation part. But now the question is, why discrete mathematics is relevant to computer science? Why don't continuous mathematics? Right? I mean, this could be a question you should be asking me. Like we saw that there's a branch of mathematics which is continuous, right? Why don't continuous mathematics be important for computer scientists? Why discrete mathematics? Okay, so let us try to answer that question. Okay, so Arsh has almost written that answer, that most of our data is actually excellent. So you already know the answer. Because in computer science, if you remember, like from your programming lectures, what we deal is often bits, right? Which is discrete. Bit, what are bits? Bits is can be either 0 or 1, right? And 0 and 1 is discrete. And everything we represent in our computer science is going to be in form of bits. So what we deal in computer science is always finite and discrete objects. Okay, so I can give you an example. So answer this question for me. Like if I have to store a real number with infinite precision, can I do that in a computer? Please read the question carefully. A real number but with infinite precision, can I do that in a computer? No, right? No matter whether I'm using a supercomputer, Tehane or Cray-X or any supercomputer, still I cannot store a number with infinite precision, right? How do we store? You should have studied this in your programming, right? How do you store real numbers? You always store them with finite precision, right? If you recall from your programming lectures, you do it in form of a mantissa exponent relation, okay, where mantissa exponent are determined, what are the size of your registers and so on, but you can only store them with finite precision. Whatever is defined by the capability of your system, that's where you will stop. Okay, you cannot go for infinite precision, right? And that is where we come back to discrete mathematics. You know, they're continuous things. We cannot handle them in our computer. So what we are going to do, we are always going to, like, suppose we have to deal with some continuous number, we'll always deal with its approximation. We cannot in no possible way store it with an infinite precision, right? Is that clear to everyone why continuous mathematics is not relevant to us, why we boil down to discrete mathematics? Yeah, is that clear? Okay, similarly, like one of the problems which we already saw, like when we modeled a road network, that all the problems that we model, okay, like if you model something as graph, all of them deal with very finite number of objects. Okay, that all brings it down to discrete mathematics. Your techniques may be different, but at the end what you're going to use, the structures you're going to use are going to be discrete. Okay, so I'll end today's lecture on this topic, that whatever you are going to study in discrete mathematics, this course, it's going to be foundation for a different subjects which you will study either in this semester or in the coming semesters. Okay, so whatever topics you study in this, you will see you will be hitting back all those topics repeatedly in subjects like data structures, algorithms, database management system, theory of computation, and many more. Okay, and those of you who are interested in gate, gate also has a very specific component of discrete mathematics. Okay, so please don't take this course lightly. So all your foundational knowledge is actually behind this course. Okay, so I'll stop there. I don't want to extend to full hour. So I'm not yet done with motivation. What I want to give next is basically practical applications of different topics we are going to study and the objectives of this course. Okay, that's what we'll start with in our next lecture. But apart from that, once we are done with that, I want to start with another topic tomorrow. So as I mentioned to you yesterday, before you start any course, any tool, what is the first thing that you should ask yourself? I told you yesterday also. Like if you start doing any project, any course, what is the first thing that you should always ask yourself? Okay, so you should remember this, that the first thing that you ask yourself is, what is the motivation? Exactly. Excellent, Jamil. What is the motivation behind doing that? Why are you doing that? Okay, so let me tell you why we are going to do what we are going to do next. Okay, so if you look at this course, like even from a perspective, like an overall perspective, it's going to deal with a lot of proofs, and you're going to write a lot of mathematical symbols. Okay, a trivial way to write all those mathematical symbols is on copy, and then you scan it and using a cam scanner and send me the scanned copy, right? But you are information technology students, so writing on paper is not the end solution. So we need a solution by which we can very cleanly, neatly write, very easily write mathematical proofs and present them, right? So of course we can nowadays word and all have those softwares to insert equations and all, but how to write mathematical proofs very cleanly and present them nicely, okay? That is the motivation behind the tool that I'm going to teach you in the next two lectures, that is known as latex. Anyone ever heard about latex?
No, no.
No. So latex like is a very hot selling tool current days. It's a good thing to add to your CV. It's not very different thing. It's like a word processing software, right? But its presentation, its ease of handling is much better than word. Okay, like you can ask your seniors also, like if you have to make some thesis, like at the end of btech you have to write a thesis, all the arrangement part and the front end matter is automatically handled by latex. So it's a very good tool to use, especially for discrete mathematics course. You can write all your proofs very neatly in this tool. Okay, so in this week I'm going to cover this course, and over Piazza I'll send you the links which you need to install. Okay, I'm not going to keep it boring as a lecture. We'll have a hands-on session of this course. Okay, hands-on session means I'll do it on screen, I'll ask you to do it in parallel. Okay, that way we'll cover it up together. It will slow us down, but we'll have a hands-on session on latex. Okay, and hopefully towards the end of this course I'll also keep a spoken tutorials exam for it, so that you have a certification also of it. Okay, so this is the tool that we are going to discuss in next two lectures, latex, and then we'll start with our first module, hopefully on Monday. Okay, so do join tomorrow for the remaining motivation applications, and do install the latex tools which I'll ask you to install. Okay, and so that you, our motive will be with every course you also keep on adding things to your CV. Okay, so we'll have this hands-on session, and I want all of you to together come upon this so that we learn it all together. Okay, so do install things, and I'll see you tomorrow. Okay, any questions? I'll stop there. It's already 11.